So welcome everyone to my talk, Attacking the Front End, where we'll explore modern day client-side security. A little bit about myself, so you're not talking with a stranger the whole time. Hi, my name is Kaif. I come from the beautiful city of Melbourne. I'm a technology and security enthusiast who comes from a software engineering background. My education and early career has been mostly software engineering. Then I switched over to cybersecurity because that's what I loved throughout. I've been working as a product security engineer at Atlassian for the last 2 years. Apart from tech and cybersecurity, I've been just a big proponent of education. So you'll see me running workshops, CTFs for university students at local meetups and etc. I also host a YouTube channel called Everything Cyber with another mate, but more on that later. Cool. So let's have a look at what the talk is about. It's going to be about, and what do we mean by modern day client-side security? So when we say client-side, we usually refer to the browser, the website, the web app, and everything that is the forward-facing interface that the user usually interacts with. So that's usually the gateway to your server and all the internal domain. So throughout this talk, we're going to see some most dangerous and high impact security vulnerabilities that happen from a client-side perspective. And then for those vulnerabilities, we'll see what are the best practices, especially from a secure coding perspective. And throughout those, for each vulnerability class, we'll obviously be sharing different resources, and we'll have time for the question at the end. Dive into the vulnerability classes specifically. Let's set the scene. Let's try to understand what's the landscape is like. So over the last few years, especially because of COVID, we are starting to see this rapid digital transformation. So these days, everything and anything seems to have a website, a web application, or some sort of online presence. And it's not always just by a choice, it's always by necessity, because if we're honest with ourselves, whenever we use something, we also expect online or website version of that available as well. So the amount of web traffic and applications has increased drastically, and how we create those web applications have changed drastically as well. So I'll ask a question to the audience, a show of hands of how many of us has created a website just using HTML, CSS, and JavaScript. So created a website just using those three. A few hands up. So that whole concept of using HTML, CSS, and JavaScript to create a website feels arcane, right? These days we have React, Angular, Next.js, Nest.js, and so many cool things flying around, and so many different ways to do things. And in the middle, we even made the mistake of PHP and quickly fixed that as well. I'm glad we're moving away from that. But yeah, the way we make applications has changed. And in that landscape, we see new kind of vulnerabilities that wasn't the case, is popping up left, right, center, as well as some pretty old classes that are still biting us. And with that, let's dive right into it. So the first one is probably not a surprise one, which is the code injection attacks. And in this case, as the applications have become more and more complex, the interaction between the user and the web applications has increased drastically. It's not just a static website anymore. There's all two-way flows going all the way. So the attack surface where the attacker can do some damage has increased as well. So think of the scenario where instead of a text, someone puts in maybe JavaScript code or SQL. Is your application handled well enough to, is your application resilient enough to handle that properly? It's not a new sort of issue. That issue has been biting us for a while. And modern web frameworks like React and Angular have some built-in protections against that. But we'll quickly see how to bypass those protections as well. Which brings us to cross-site scripting. And that's the code injection attack class I'm going to focus more on. There's other classes like SQLi, but XSS in React and Angular is pretty common, and we're going to see how. But again, just this question is more to set the pace of my talk, because if you do not know what is XSS, React and XSS in React and Angular doesn't make sense. So show of us, how many of us already know what is XSS, how it happens, and what is the protection against it? Majority of the room. That's good. I still see some hands not raised, so I'm just gonna do a baseline run through very quick. So the people who already know, please bear with me. I'm not gonna spend too much time on it. So XSS or cross-site scripting is basically when your code is, your application is vulnerable and the attacker can inject or submit their own malicious code, and because of vulnerability in your web application, the browser runs it. So long story short, the browser is not the issue here. It's how just we have created our browser. Whatever the web application gives it, it's going to run it. And it's up to our application to sort of verify what is genuine code and what's not. And XSS can, in the old days, we used to see a lot of old-style website defacements during the anonymous. They used to do a lot of that. But in modern times, XSS can be used to do full account takeover as well. And a very small example would be if you have a search bar and you put in something like potatoes, it is text, the website functions. But what if you put in code? Does your website allow to run that as well? So that was a very basic thing. And just another visual example. Let's say I have an attacker whose target is to get the session cookies, and outcrafts a malicious URL like this and send it to the user, and the user clicks it, and because this insecure website, it is insecure, it will run this code instead of just running text, and the attacker will just get the session cookies. Again, pretty basic stuff. If you want to learn more, please do. But the reason I'm covering XSS is it usually has very drastic real-world impact. So some of the biggest bounties we have seen do come from XSS, both not just in Atlassian, all over the industry as well. And some of the XSS vulnerabilities are quite scary as well. Cool. So that was the borderline. Let's try to understand how XSS happens in React. That's what we're all here for. But to understand that, I want to ask the audience another question. Which one of these do you think is the best protection against XSS? Now, all of these can be used in coordination, yes, but one of them is the best one. Is it use some sort of encoding? Is it input sanitization? Is it context-sensitive output encoding? Or using CSP, context-free policy? Any guesses? 4, 2, 3, a lot of these, 1, it's all over the place. That's correct. All of these can be used in conjunction, but the best way to do is actually number 3, context-sensitive input output. Because when you're outputting the data back to the application, you do know the browser context, the application context where the data will be going. Whereas the issue with number 2, input sanitization, if your application is purely simple, yes, you do know where the data will go out in terms of the application context. But if the application is relatively complex, you really do not have any controls. That's why we see so many input sanitization bypasses as XSS as well. CSP, yes, is a great protection, but it's an additional layer of defense. CSP is not a replacement of actual defensive coding. And the number 1 is just trash, it doesn't do anything. Cool. So now let's understand what React does. So React comes with React's interpolation mechanism. What that basically is everything you put in React, whether it's text, it's numbers, it's code. In usual cases, React will do input sanitization, which means it will output everything as just raw string. So let's say if I have a React form like this and you submit some code, even if it has code, it's going to just output everything as a string like it has in the bottom. No, nothing changes. So yeah, React is safe against XSS. That's it. Next for my talk, and you can wrap up. Unfortunately, that's not the case. There are multiple ways you can bypass that input sanitization, and lots of ways you can do damage with React. The 3 major ways is not using dangerously set inner HTML properly, something called React escape hatches, and finally proper encoding of different HTML elements. And we're going to dive into them a bit more. Now, before doing that, you might ask that, hey, if React outputs everything as string, why can't just we leave it at that? Why do we need dynamic content generation from the user? A lot of the things we do in a modern website is dynamic content generation from the user side, even though we might not think like it is. Like it's not always you put content in the bold tag of HTML and it will automatically pop up. So this is one of our products, Confluence. So we have an Atlassian. It's pretty much a text editor, similar as Google Docs or whatever. What it basically does, it allows the user to do all kinds of text formatting as well as adding comments, iframes, and lots of other things. And that's a very good example of you do need dynamic content generation from the user. It's probably a bit more extreme case where you're doing that, but in all of our modern web applications, you're doing it in different capacity nonetheless. So yeah, with that established, let's look at the React XSS attack vectors and how it can happen. So if you wanted to do dynamic content generation in React, the way to do is something called dangerously set inner HTML. That's dangerous, yes, but that is the default way of doing so. And if I rewrote that form with dangerously set inner HTML, and if it basically accepts everything and outputs everything as well. So if I just rewrite that form with this dangerously set inner HTML function, it will, and I put an input like this where there is HTML elements, it is going to output that HTML element because that sort of removes that built-in protection React was giving, which is completely fine. That's what it's meant to do. That's why we rely on third-party libraries like DOM Purify to actually sanitize that HTML and properly make that insecure HTML into a safe one. All fine and dandy. But the problem why dangerously set inner HTML is a pretty big issue is actually the guidance that is provided. So if you quickly Google how to do a dynamic HTML content generation, this is not something I've written. This is actually React's own documentation from its website. So it will take you to dangerously set inner HTML and it will tell you that, hey, yes, you use dangerously set inner HTML to do dynamic content generation. Yes, it is scary, it is risky, it can cause something as XSS, and that's pretty much it. It is relying on the developer to first find dangerously set inner HTML, understand what are the risks, understand what is XSS, what impact it can have, and all that stuff, and then go find a proper implementation of it. And I've seen so many threads in Stack Overflow where someone's asked, how do I do it? And someone has pasted dangerously set inner HTML but did not mention DOM Purify or any kind of sanitization. So if you Google dangerously set inner HTML this is just a quick search in GitHub, you find over 1 million hits or usages of dangerously set inner HTML. Now, whether all of them are actually a potential risky sink, probably not. But can we also guarantee that all the developers, especially the small to medium companies who have a lot of resource constraint, they went out and did the proper documentation, research, and have implemented this properly? The answer is probably no. And that's why we see a lot of XSS happening using that. So how do we defend against that? The good news is most modern static code analyzing tools will pick dangerously set inner HTML up, and if you use something like that in your code, in a component, it will pretty much flag you this kind of warning. So in this case, I'm just using sendgrep as a just example, but it will give you something like this. However, this is just one warning in one file. In a modern, pretty much industry application, you have hundreds of thousands of files. So that one warning can easily become 5 warnings, 10 warnings, 100 warnings, or even thousands. How do you really understand which warning is the correct one and you have already dealt with, and which warning is something new, a risky thing the developer has introduced? That's why most people advocate for creating a separate component. And for those who do not know, are familiar with React components, think of it like a Lego block. Once you have created it, you can use it in multiple places in your web application. So the ideal way is you create a HTML component like this, which handles the risky data coming in, and you use that component everywhere across your code. So let's say in this case, I've named myself this component a safe HTML, and that handles the dangerously set inner HTML with DOM Purify, and I use that same component everywhere across my code. So that way, when I run a static code analyzer, it will only give me a hit in the safe HTML.js file, let's say. And in my other files, it's not going to complain because I'm just using directly that component. And if I'm a security engineer or developer and I have that, and then I can see another alert pop up in logging.js or in some other pages, then I'll know that, hey, maybe someone has created something custom, and that's my cue to go in and check in. And that's why you can really mitigate the number of alerts that can happen. Cool. More real XSS attack vectors. That wasn't the only way. So again, a quick question for the audience who might already know. What do you think is a React escape hatch? Is it number 1, 2, 3, or 4? I wish I could play the Kahoot music. Any guesses? Number 4? And that's correct. An escape hatch is a way to directly access the native DOM. So for people who know React, how React works is it creates a virtual DOM. Think of DOM as your website or your web page. So it creates a virtual layer over it, and you build everything directly. You never directly work with the underlying actual browser. In this case, the website. I don't want to call the website and DOM the same thing, but think of it like this for people who do not know, are not familiar with React. But what React also allows you to do is, instead of working with the virtual DOM, you can circumvent that and go directly into the actual web page and manipulate the HTML directly from there. That's what we see something, functions like find DOM node and create ref. You might think it's safe, but it directly inputs whatever you get into that DOM. And again, it does not come with any kind of sanitization or checks by default. And unlike dangerously set inner HTML, this kind of escape hatches are much, much harder to deal with because it's not just one place where you can chuck in a library in front of it and just be done with it. So this DOM issue is actually so bad, it's considered an anti-pattern, and React knows it, and it's looking forward to depreciating that in future versions of React. So that method find DOM node will be depreciated, but we do know that in the actual industry, not everyone runs the bleeding edge. Oftentimes, we are working with older versions of React, and in those places, escape hatches can still exist. One alternative approach was suggested to me by a friend that maybe if you want to use an escape hatch for whatever reason it is, instead of an inner HTML, you can use something called inner text that automatically converts everything into a text. Again, that's something I haven't tested myself, just throwing it out there for people who want to. And if you're a Pentester or a security engineer or someone who's in charge of those, finding those issues, looking for things like find DOM node, create ref, inner HTML, outer HTML, directly reference from your React application is a good way to, it's a good starting point to check and test. Alrighty, let's look at some other ways you can hack React. Again, a question to the audience. Which one of these HTML elements do you think can be used to run code, run JavaScript code? Is it URLs, CSS, Markdown, or all of them? All of them? All of them. True. You can use all of these things that usually seem very safe can be used to run JavaScript code as well. So if you're a web developer and you're not handling these elements securely, that can cause issues. And I'm going to in particular focus on URLs because that's what that happens the most. So JavaScript and on all the other kind of resource URLs can actually be a potential sink for XSS. Now, when the URL is hard-coded, it is not an issue, that's fine. But as soon as we open it up to the user to input different kinds of URLs, we are making ourselves vulnerable. Let me give you a very quick example. A lot of the times we've seen developers, they handle HTTP URLs pretty well. So it's your regular URLs, HTTP or https.www.something.com. That's fine. But did you guys know that JavaScript URLs exist? And you can actually, this is considered also an URL, and this is pretty much raw JavaScript code. You can chuck that in the URL field, and that will just run that code. So if you're a developer who are not aware of these kind of things, and you're not doing proper sanitization, this can cause a lot of issues. Again, the React security team is quite competent. They know about these issues and they're looking forward to blocking these. For example, even in current versions of React, if you use JavaScript URLs, it's going to give you this big red warning that, hey, it's dangerous, you shouldn't do it. But it's just a warning. And back in from my software engineering days, if I see a big red warning, but my code runs, I just tend to ignore that big red warning, right? And just be on with my life. And so a lot of people might miss that. And it's still a case in older versions. Another thing to call out is this is just for JavaScript URLs. There's something else called data URLs. So data URLs, React is not doing much with it. So that can be another potential sink. That's where CSP comes in. This talk is slightly a bit fast-paced. It was initially designed 1 hour, then I suddenly realized it's 30 minutes, so a few things are a bit switched. But yeah, look into how you can detect data URLs using CSP if that's an issue. So how do we defend against URLs and properly handle them safely? One way I've seen a lot of people do is avoid taking the full URL and instead take part of it. So imagine you making a website and that will embed YouTube videos into it and the users can chuck in that YouTube video. Instead of maybe putting in the whole YouTube link and having to deal with URL sanitization and all this stuff, maybe you can take in just the video ID and have that your YouTube URL hard-coded and you put that together and then upload it. That reduces it significantly. But I know that that's a utopian solution and it can't happen all the time. So that's why URL sanitization comes in. Now, the reason I haven't dug very deep into it is because React's URL sanitization is not the best because it tries to do blacklisting of stuff, blacklisting of known bad URL types rather than whitelisting of just good URL types that we care about. And the security professionals in this room would know that in security, we generally prefer whitelisting of good stuff over blacklisting of bad stuff because more bad stuff can come and it can bypass. For that, Angular's URL sanitization library is actually quite good. I've seen a lot of people, what they do is they look at Angular's library and encode that into React all by themselves. That is a potential good alternative to do as well. Cool, so how do we prevent XSS in React from a very high level view? So securely handling dynamic content is a big one, and creating some kind of custom component and using that everywhere is the way to go. And it is along with that concept of secure by default. That is a good example of that, where in our case, our security team have created a few components that we just encourage our developers to use in all places. And it's not just HTML content dealing with that, it's also authorization, authentication, and lots of other things that you can make secure by default. If you're doing DOM manipulation manually, please don't. Use something like dangerously set in HTML instead, where you can handle that a bit better. And lastly, be mindful of other type of HTML elements because that can be potentially dangerous as well. And if you want to play around with a few different vulnerable React applications, I'll just put in the names of this something called React Vulna and React Suspended. They're deliberately vulnerable React applications to sort of test and understand your code. I haven't put the link because if you just Google vulnerable React apps, they probably pop up. Cool. Another thing is I have not covered something called trusted types. So it's a new defense mechanism that's coming on. It's a sort of leading edge research for React and XSS that's being led by the Google security team. That's something to call out as well. Okay, that was all the nightmares with React. What about Angular? How's Angular with XSS? So the good news is, actually from my experience, Angular by default is quite better compared to React when it's come to just security. Now the developer experience side aside, I'm not going to comment. Most people prefer React over Angular and sometimes for good reasons as well. But if you're looking at just from raw security perspective, Angular does very good. So let's look at what are the default security mechanisms Angular has. The first one is very similar to React, which does automatic input sanitization. So if you have, there's something called Angular strict contextual escaping, which is just a fancy way of saying input sanitization, honestly. You put in this case, this text block is created with Angular, and I put in, let's say, malicious code. It will output everything as string, very similar to what React does. But wait, there's more. So what Angular does is not only input sanitization, it also does output, context-sensitive output encoding by default. So remember the thing we talked about is the best way to protect against XSS. Angular does that out of the box. There's something exists in Angular called, Angular called inner HTML. So this is separate from the browser's inner HTML. So that's why I put it in the square brackets. So if you use the inner HTML, it does context-sensitive output encoding by default. And what the heck do I mean by that? I've been explaining that out for quite a bit. So let's say if I had an Angular app and someone submits this malicious piece of code, not just in this case malicious, but more like if someone tries to run JavaScript. So what Angular will automatically do, it will keep the safe HTML, in this case the image, and it will automatically remove the JavaScript bit, which can be a bit riskier. So it's taking care of the good parts, and it's getting rid of the bad parts. Just to make it a bit more clear, I've got those two Angular mechanisms side by side. So let's say I have a comment box, and I put in something like this, where I have HTML tags, scripts, lots of different things. So input sanitization, Angular will not do anything. Angular will just output everything as raw string. But if Angular's context-sensitive output encoding, it's going to keep the bold tags, and it's going to get removed of that script. And in the browser console, it will also give us a warning that, hey, I've done some sanitization because of XYZ, which is great. Does that mean it's all rainbows and sunshine in Angular world? Unfortunately not. Certain things do happen in Angular as well. Cool. I'm just mindful of time, so I'm going to breeze through this talk slightly more than usual. So Angular XSS is definitely possible, and one way to do is this thing called bypass security trust HTML. It's very similar to dangerously set HTML function. You can bypass pretty much everything. The next bit would be similar to React. You can also do native DOM manipulation. We have already talked about it and why it's bad. And the thing that I'm going to make a special call out is the render to API. That's a built-in API that Angular provides. It's actually an official DOM. It uses the same native DOM manipulation, and you can do the same things with Angular. My apologies, I'm just being mindful of the time and quickly running through. There's something called template injection attacks in Angular. That's a bit more on the server side, but because it is so drastic, I decided to make a call out just in case. How do we protect against XSS in Angular? The default mechanisms Angular provide is quite safe. So as long as you're sticking to the default, it's quite good. And if you're doing any kind of custom DOM manipulation, you need to be very careful. And lastly, template injection attacks, again, something to be mindful of. The next bit is basically, imagine a scenario where you have a website and there's an account recovery mechanism, and someday you wake up and see your emails change. Someone has mysteriously managed to change the backup email. That's a classic example of cross-site request forgery attack. Cross-site request forgery attacks is a very drastic one, which had severe security implications. It almost stopped TikTokers from making dance videos for a whole day. That was quite big. So how does CSRF mainly happen? So there's three conditions for CSRF to happen. One is a relevant action change. In that case, in most stateful websites have that, which is, let's say, a HTTP request to some sort of website, some sort of API. The main issue with CSRF is where CSRF happens is the cookie-based session handling. So if you're relying on just your authentication of specific tokens or cookies to do session handling, that's a big no-no. And there's no unpredictable request parameters. Cool. So again, the root cause is when you use your authentication of session tokens, or just your regular session tokens to, sorry, not regular session tokens, just your authorization authentication tokens to do session management. Because there's no way for your server to know where does the request originate from, and that's a big issue where CSRF can happen. And if your website is just relying on that, I can craft a payload like this, which is a hidden form or URL, and I send it to, let's say, to the user, and if the user is logged in, because they have their session tokens saved inside the browser, they'll click on the link, this will work, and because your website does not have any protections against where the request is actually flowing in from, it can cause CSRF. How do we protect against that? CSRF tokens, I'm not going to go into this slide in depth. I'm going to share the slides afterwards. You can look into it. But basically, the long story short is use some kind of CSRF tokens to protect against these kind of attacks. A lot of the web frameworks by default come with these libraries, but the thing is, it's not automatically turned on. The developer needs to go and include this as a middleware or something else, and that's the step often people mistake. So just to quickly, how within Atlassian we've been combating CSRF. So we have blocked all kinds of state changes using the GET request, because then your CSRF tokens can't even do anything. And yes, if you didn't know, you can make state changes using GET HTTP command, not just a post, using something called same-site cookies tokens, again, for something for you to investigate. And lastly, apart from CSRF tokens, we also do have an API gateway that does the course whitelisting, so it pretty much hydrates the request with a few more headers. So we looked a lot about, I'm just going to use the last 2 minutes of my time to actually go through this. If you have any questions, please find me afterwards, or I'm just going to share how to reach out to me afterwards. We discussed about our own code, but what if other people's code? And this image, I really love it, because that's actually true. Whenever I'm creating a new project, I do npm install 5 different libraries, and as a software engineer, taking code from Stack Overflow and other places is very, very common. But do we actually know if other people's code is actually secure? And this issue there is a prime example where it used to be, I'm not going to name shame the actual npm package, but it was basically, it was very widely used, very popular, but it's open source. The maintainer doesn't get anything out of it. So after years of maintaining it, when someone just offered that, hey, I'm happy to maintain it for you, and here's some money, the maintainer just gave it away. Go use it. That's fine. And that buyer was malicious, and what they did next is just release a new update, and all the developers were like, ooh, new update of an unmaintained library for 5 years, I'm going to go update that. And basically that update was malicious, and a lot of things got applied. So third-party library vulnerabilities is a big thing, and supply chain has been the theme of this year. Like say has gone 3 times these days, and Genie will accept your wish. So these are the top 10 NPM libraries, at least at the time, and if you look at the vulnerabilities that exist there, most of them, or 6 out of the top 10 have something. How to protect against these? Use some framework like Salsa is a good one, using tools like OAuth dependency check, Sneak, SCA, again, good one. My hot take is, unless you really need to, stay one version behind the leading edge, because you really don't know that latest push. Is it a malicious actor, or is it an actual update? If you're one of the persons who write those NPM packages, this article is for you. Again, I'm not going to go in depth, but if you search this, you will find some very good info. Some cool hacker resources, I follow them quite a bit. I switched from software engineering to hacking, cybersecurity, and my job has become copying stuff from Stack Overflow to copying stuff from Matrix, basically. Cool. 2 last things. Thank you so much to the organizers. It has been an amazing conference. And one last shameless plug is, if you like this talk, I run a similar many talks in my YouTube channel called Everything Cyber. You'll find a link there, as well as the link to this presentation slides there. Thank you so much.